different places where we've seen this uh, famous shape here before, this lovely parabola. We talked about a fishing hook. We talked about a football being thrown. We talked about a saxophone. We talked about the famous McDonald's arches. We talked about shopping bags. We talked about a rainbow. We talked about when you throw something, and we talked about a boomerang. So we've talked about a lot of places where we've seen this famous arch before. Now leads us into today's lesson, the zero product property. So if you turn to the front of your spiral notebook, and in your table of contents, go ahead and write today's objective, and then turn to that page in your spiral notebook and write that objective down. So today's lesson is zero product property. This is how we find our x-intercepts on our graph. Just to give you a heads up, they are also known as roots or zeros also. And I'm going to try to use them, all three of those vocab words interchangeably. X-intercepts, roots, and zeros, so that you feel comfortable knowing all three of those are synonyms and finding the exact same thing. In my class, in about a week, I'll show you how to use that graphing calculator to find zeros using your graph. Yes, and so in my calculator, you go to the word zeros to find that. Now raise your hand if you can take Algebra 3 next year. Mr. Williams' calculator, you actually have to go to the word root in order to find the zero. So roots and zeros are used interchangeably in this class. Same exact word. So here is our first question to write down. And I have a question before I actually show you the math behind this. Where have we seen something like this before? What? Factoring. You actually did this on Friday for a quiz, right? You made it look like those two sets of parentheses. So this is where that is. Where else have we seen this other than factoring? Graphing? Who said it? Jesse? Graphing is a great place. And when you saw this with graphing, what did we do with them? Anybody remember? What? How'd you find that, Jesse? You're right. I think you're half right. I think that's where you were dressing up with foiling. But we don't need to foil these. We actually, whenever we were graphing them, we set them equal to 0. And what did that find when we set them equal to 0? Those are my x parts, right? My two x-intercepts. That's what our lesson's on today. That's it. We are going to be setting these pieces equal to 0 to find the x-intercepts, the root, the 0. So let's do that. Oops. Try again. X minus 7 equals 0 and 2x plus 3 equals 0. So go ahead and solve both of those equations. So here I have x equals 7. And over here, I'm going to have x equals negative 3 over 2. Raise your hand if you got those there. Fantastic. So now, we've already graphed by hand, so I'm not going to make you do the whole graphing by hand again. But we are going to use those graphing calculators. We're going to type that equation into our y equals and go ahead and graph. So I'm going to take my graphing calculator, and I'm going to type it into my y1 right there for all of you. I have all those other ones in there just to help me out for later, that's all. So you're only typing in the top one. And that's it. We always want to type in the original if we can. go ahead and hit graph, and I'll give you guys a few seconds to go ahead and hit that graph. So here, as I'm looking at my graph, I want to see where does this cross the x-axis. And this is at about 1, 2, 3, 4, 5, 6, 7. And doesn't this look like it's at about maybe -1.5 or -3.5? Right? That proves we were right. That's a quick way to check my answers, isn't it? Okay. So let's go ahead and try our next problem. Here's our next. Now, what's different from this problem versus the last problem? It has an exponent. Sarah? It doesn't have the parentheses. That's the big one. It doesn't have, how can I make parentheses? What? Yeah, yeah. Bednar. Bednar, you're close, Deb. Go ahead and use your Bednar method. Now, here's one thing I want to point out. We can use the Bednar method because it's equal to 0. But while you're doing the Bednar method, pretend the equal 0 is not there. Okay? So when you cross out the 3, what are you going to multiply it by? By the 3, right? Not by the 0. So go ahead and do your Bednar method. So I'm going to go ahead and set these equal to 0. And you should get x plus 3 equals 0, 3x minus 1 equals 0, x equals -3, and x equals 1/3, right? How many of you have that? Okay. So now let's go ahead and graph it. Which equation should I graph? Should I put in this one right here? How about this one? I'm going to say no. I probably want to go clear up here. Why? What's a good reason not to type this one in, the factored form, and go up here, balance? Exactly. I've made mistakes before. Sometimes I make mistakes in here, right? So you always want to type in that original question, at least as far up as you can, where you would have made the least amount of mistakes. So I'm going to type in my graphing calculator. This one right here, the 3x squared plus 8x minus 3, and hit graph. And now I can see that it's crossing at about 3 and at about positive 1/3. Now, Jesse actually did this problem, and he forgot to divide with Bednar. Okay? But raise your hand if you've ever forgotten to divide with Bednar. Look, even my hand's up, okay? It happens, right? How quick was it for you, Jesse, to look at it and be like, oh, wait, and these are his exact words. I forgot to simplify. That only took like 10 seconds for you to realize, right? And now he'll know he has the right answer on the test. I want to give you an A, and here's the easiest, quickest way to get there. Okay. So now that we've checked that answer, let's go a step further. Let's try this problem. We're okay. I think we can try this. So my first question, what's different between this one and the ones before it? Okay, I need to get all my x's. It doesn't equal 0. So when Jesse was saying I need all my x's on one side, he's actually thinking about how do I get it equal to 0. How would I get this equal to 0? Give me one step. Somebody raise your hand. Give me one step. Okay, you're right. Can you tell me how to move just that piece over? Right. Okay, now I'm going to come back. How do I move this piece over? Yep. You explained it in a way to do the entire thing at once. You can do that. Is that something you've done before in the past? Right. We've all done this one before in the past. Okay, so now I have 2x squared minus 20x plus 50 equals 0. What do I need to do now? That is the part most people forget. GCF. Go ahead and factor this, starting with GCF. So I went ahead and I pulled the 2 out of everything. So I have 2 times x squared minus 10x plus 25. And what does that factor into? What times 1 is 25 and adds to negative 10? Excellent. Negative 5 and negative 5. Now, you could write it this way, or some of you may write it this way. X minus 5 squared. Because there's 2 of them. Raise your hand if you wrote it the second way instead. Perfect. And it does not matter. But this actually leads us into, if you're taking algebra 3, that will lead you into that. But let's check our answer. Which one should I type in? Can I type in the original line? I can't. I cannot. You know which one I'm going to type in? This one, that's equal to 0. Now, maybe I made a mistake, but I can't type in that top line. That's the closest line up that I can type in. So I'm going to go ahead and do that. And there's my lovely graph. What's different about this graph versus the other graph? That's it. Notice that the intercept, this is the key thing, it only comes down and touches it, right? Well, how many x equals 5 did you get? 2. And if you have the x minus 5 squared, technically you have 2 if you put the square there, right? When you take algebra 3, Mr. Williams actually starts the year talking about multiplicity. And this is considered having a multiplicity of 2. Because you have 2 of the exact same x-intercepts. And anytime that happens, the graph will come and just touch that x-intercept and bounce right back up. Because I set that equal to 0. So I actually need to write x minus 5 equals 0. So x equals 5. Good catch, though. Good catch. Okay. How do we feel with that? Okay. I'm going to give you one final problem. So if you notice, we walked through most of those ones together, right? This one is you and your group only, so if you need a little bit of assistance, you can ask your group. Last and final problem. It looks large, but I think you guys are fine with it. Take it little step by little step. Notice I didn't start you with this problem, right? So no panic. So up here, we went ahead, we got it equal to 0, bednard it, crossed things out, simplified. I'm actually going to rewrite it. So she simplified her fractions right here beside it. But I'm just going to write it like this. X plus 5 over 2 and x minus 1 over 3. There's a reason I'm writing it that way that I'll show you here in a second. But before I do that, over here, let's rewrite with the 2 in the front and the 3 in the front. So 2x plus 5 and 3x minus 1, right? So now I'm going to set this first set of parentheses equal to 0. 2x plus 5 equals 0. We'll subtract 5. So 2x equals negative 5. Divide by 2. And x equals negative 5 over 2, right? Now, some of you may be able to see this and do this a little quicker. If this doesn't make sense, please do it this way, okay? But if all of a sudden this flips, and I'm going to guess for Jesse this will flip. And all of a sudden he'll be like, can I just do it this way? And I'll say yes, okay? You notice right here, if you just set this part right now equal to 0, what would it equal? Wouldn't it equal negative 5 halves? Right? If I just subtract 5 halves over to the other side? So what would this one right here equal? So if you don't want to have to do all this work right here, you can skip straight to your answer. You got it. Notice the only way you can do that though, there's no number in front of that x. You haven't moved that 3 over yet. Okay? Now, if that doesn't click with you, please go ahead and stick with this method. It always works too. Okay? Any questions? At this time, turn back to the back of your spiral notebook. So those things you wrote down, right? You had those items that you wrote down.